Hello, so today I'll solve this 2009 AP number 1 question. So this was from actual AP Calc BC. So this is graphing calculator section, so you're allowed to use graphing calculator. So when we read the question here, we can tell that this graph here is the velocity graph, and it is in terms of t right here, which is by minute. So basically the story is this girl called Karen is riding a bicycle in the following velocity, each corresponding time starting from 0 to 12 minutes. So the first question, the part A, is asking us to get the acceleration at time equals 7.5 minutes. So the very beginning we learned that the acceleration and the velocity graph, so velocity, the relationship is the acceleration is the derivative of the velocity. So this is the very fundamental, very basic relationship we learned in calculus. So by using this, we can get the acceleration at 7.5, which is derivative of velocity at 7.5. So we learned that velocity, the derivative can be slope at that time. I mean, it should be instantaneous rate of change, but in this case, at 7.5 here, this whole slope, they have the same instantaneous rate of change, so the average rate of change, they're all the same. So we want to get the slope at 7.5, which is all the same throughout from 7 to 8. So when we use the rise over run method, the run is from 7 to 8, so it's 1. And when the time moved from 7 to 8, the actual velocity dropped from 0.3 to 0.2, so that's negative 0.1. So the slope is negative 0.1. So that means the acceleration at time equals 7.5 minutes is negative 0.1. And the unit is meter per minute square, because it's based on the minute. Okay, so that was part 1. So part 2 is asking us, using correct unit, to compute to get that value of that notation there and the meaning of it. So that is the integral of the velocity from 0 to 12. So we learned that the integral in the graph can be recognized as the area of it, and because there's the absolute value sign here, we're not getting the displacement, we're getting the total distance. So this notation right here, the integral from 0 to 12 of absolute value vt dt, is this whole area, this triangle, this whole weird looking shape. So it's easy because they're not in like any like polar, like circular shape. They're all in a good shape, like triangle. Is easy to get the area of it. So basically from 0 to 2 we got this triangle, right? So this is 2 times 0.2 divided by 2, which is 0.2. So 0.2 plus this triangle here is negative 0.2, but because we have absolute value, we just add them, not subtract it. And when we calculate this whole thing, for me, this is easier, so I'll just divide it like this section and get each area from 5 to 7, from 7 to 8, and from 8 to 12. So they will be 0.45 from 5 to 7 and 0.25 from 7 to 8 and 0.7 from 8 to 12 minutes. So when we add them up all together, add these up, ends up being 1.8. So 1.8 is the area of it, which is the total distance. This means the total distance that Karen traveled from the start to 12 minutes. So, because this is just distance, the unit is meter. So this is the value of this notation. And for C, part C, so Karen realized that she left something, so she turns back, and we want to know what the time is when she turns back and go back to her house. So she leaves from her house at zero, right? And so this is velocity graph. So she travels. This positive means she's going to one direction, for example to the right, for the whole 2 minutes, and then from t equals 2, the sign changes from positive to negative. So that means in distance term that the direction of the direction changed from right to left. So that's the when time equals 2 is the first time when the sign changes. So that means she left her house at 0, and that at time equals 2, she turned back to her house again to get something. So that time t equals 2, because that's the time when her sign of velocity changed, which means the direction of her displacement changed. So part D, there's a new character called Larry, and Larry also travels to school for 12 minutes, but his velocity model is different from Karen's, which is given the formula here, equation. So we have to know who lives closer to the school, Karen or Larry. So in this case, we gotta be careful. We're comparing who's closer, so we should not compare the total distance, which is what we got from B. We have to compare the displacement, the net distance from Karen's house and Larry's house to the school. So what we have to do here is actually calculate from 0 to 12 Vt, which is Karen's dt. We don't need absolute value like we did in part B, because it's not total distance. We don't need that negative part. We gotta cancel everything out to get the displacement, which is net distance. So we can calculate this by same method from B. Because we don't have the equation of the velocity equation, we need to get through by using just getting area of the whole graph. And Larry, in this case, we don't have the graph, but we got the equation. So from 0 to 12, his velocity is Wt dt. And in Larry's case, we can just compute it in our calculator, because this is graphing calculator section. So when you plug in Wt, which is here, right here, into the calculator and integrate it in the interval of 0 to 12, we get 1.6. So this is 1.6 here. And Karen, from up here, what we all need is this area right here, because these resembling triangle will cancel out because it's the displacement. So they were 0.2, 0.2. So we will end up with 1.4. So Karen, the displacement of Karen from the school to Karen's house is 1.4, and Larry's is 1.6. So when we compare them, obviously Karen is closer because the displacement is shorter. So Karen is closer. Thank you.